Hey makers, welcome back to Hub360 Embedded Sphere, your go-to series for building amazing embedded projects. In part 4 of our two-wheel drive robot series, we are taking things up a notch with RF remote control using the 433 MHz RF module. This lets you control your robot with a joystick-based transmitter, no Bluetooth or IR required. And the components we use are one Arduino Uno for the receiver, one Arduino Nano for the transmitter, one L298M motor driver, then the 433 MHz RF transmitter and receiver module. Then we have the joystick module, the jumper wires, breadboard, and LiPo battery and battery holder, then the 9 volts battery. Now let's go to the connection. Receiver Arduino Uno, RF receiver to Arduino. We connect the data pin to D11 on the Arduino. Okay, now let's go to the connections. Receiver Arduino Uno to RF receiver to Arduino. Wait, no, that was wrong. Receiver Arduino Uno. Why did you put receiver Arduino? Doesn't receiver to Arduino. Alright, now let's go to the connections. RF receiver to Arduino. First, you connect the data pin on the RF receiver to D11 Arduino. Next, you connect the VCC pin on the RF receiver to the 5 voltage pin on the Arduino. Next, you connect the GND pin on the RF receiver to the GND on the Arduino. Now we connect the motor driver to the Arduino. First, we start by connecting the enable A pin on the motor driver to D6 on the Arduino. Next, we connect the in1 pin on the motor driver to the D13 pin on the Arduino. Next, we connect the in2 pin on the motor driver to the D7 pin on the Arduino. Now we connect the enable B pin on the motor driver to the D3 pin on the Arduino. Then we connect the in3 pin on the motor driver to the D5 pin on the Arduino. Now we connect the in4 pin on the motor driver to the D4 pin on the Arduino. Okay, now we go to the motors connection. We connect motor A output to the left motor. Then motor B outputs to the right motor. Then the motor driver's VCC to battery positive. Then the motor driver's GND to Arduino's GND and to the battery negative. We are done with the motors connection. We go over to joystick, connecting joystick to the Arduino. In this case, we are using Arduino Nano. Now we connect the RF transmitter to Arduino Nano. First, we start by connecting data pin to D12 on Arduino Nano. Next, we connect the VCC pin on the RF transmitter to the 5 voltage pin on the Arduino Nano. Next, we connect the GND pin on the RF transmitter to the GND on the Arduino Nano. So now, we move over to the transmitter connection, connecting the transmitter to the Arduino Nano. Now, we connect joystick to Arduino Nano. First, we start by connecting the VRX pin to A0 pin on Arduino Nano. Now we connect the VRY pin on the joystick module to the A1 pin on the Arduino Nano. Okay, next we connect the SW pin on the joystick module to D6 pin on Arduino Nano. So we connect the VCC pin on the joystick module to the 5 voltage pin on the Arduino Nano. Finally, connect the GND pin on the joystick module to the GND on the Arduino Nano. So we connect the GND on the joystick module to the GND on the Arduino now. Now finally, we connect the VRY pin on the joystick module to the A1 pin on the Arduino now. Important point to take note of: make sure both systems share a common ground with their modules. Connect the high watts 9 voltage battery to the V-in and ground of the Arduino Nano. Okay. Now, important point to take note of: make sure both systems share a common ground with their modules. Okay, now here we are explaining. Okay. Transmitter code explanation. These libraries include the Radiohead ASC library for RF communication and SPR support required by RH-ASC. Pin setup: A0 to joystick X-axis, A1 to joystick Y-axis, pin 6 to joystick push button. RF transmitter uses this library's default pin, D12 for Arduino Uno. Setup function: start serial monitor for debugging, initializes RF transmitter with driver int, and sets joysticks pins as inputs. Loop function: reads X and Y values from range of 0 to 1023 and button state 0 or 1. Formats them as strings XY button. Sends via driver.send and waits until sent. Prints the serial monitor for testing. This code continuously sends the joystick's position and button status to the receiver. Receiver code explanation. Libraries, same as transmitter, required for RF data reception. Pin setup: enable A to pin 6, in 1 to pin 13, and in 2 to pin 7, left motor. Enable B to pin 3, in 3 to pin 5, and in 4 to pin 4, that is for right motor. RF receiver uses default RH-ASC pin, D11 for Arduino Uno. Setup function: sets all motor driver pins as outputs, initializes serial monitor, starts RF receiver with driver.init. Motor functions: control motor speed / direction with analog write for enable A and enable B, and digital write for in pins. Delay is added for smooth movement, then stop motors. Loop function: waits for data from the transmitter. If data is received, null terminates it to form a valid string. Passes it using scanf into X val and Y val joy button. That's the joystick button. Motor decisions: forward, backward, left, right, stop if joystick centered or button pressed. Upload transmitter code to joystick Arduino. Upload receiver code to motor Arduino. Power both Arduinos. Move joystick and watch the robot obey instantly. Stay tuned for part 5. Like the video if it helped. Subscribe so you don't miss the next tutorial. Order your parts now at hub360.com.ng. Nigerians go to store for embedded hardware. Until next time, keep building, keep innovating. This is Hub360 Embedded Sphere, helping you bring your ideas to life.